I hope I'm audible.
Yes.
Okay, okay, perfect. I will just show that connecting to server. So, all right. So this is all defect. Similarly, anything more than 5.5 is all defect. So the only quality we are left with is this area. That's it. That's what is the yield of my process. That's the quality of my process. I want to find out how much is that. So one minus the total defect, which is the this side defect. I will say this lower side defect towards the lower side, and this one is the upper side defect. If I add these two defects, that's my defect only. Less than 4.5, more than 5.5. So yield will be 1 minus the sum of total lower side plus upper side defect. All I want to find out is how much is lower side defect, how much is upper side defect. I'll add them up and subtract from 1, which will give me the yield. The formula now here is lower side defect. You want to find out, and the upper side defect formula. Let's have a look at this. The formula is norm dist for normal distribution. It's there in everyone's Excel, so no need to worry about that. So norm dist, open up the bracket. Now it's asking you the value of x. What is the value of x in this? Now, what does it mean? Anything which is less than what value? You're calculating the lower side effect. Less than what?
4.5.
Absolutely, yes. So it's saying anything less than 4.5 is a defect. So value of x is less than what value is a defect? It's 4.5, comma. It's asking for mean, the average of the process, my 5.1.
5.1.
Perfect. The standard deviation, 0.2, comma. Cumulative, by default, keep this in mind, it's 1. And I'll explain what is the meaning of 1, what is cumulative. For now, remember, it's always default 1. I'll explain the one part of it. For now, remember, it's always 1. That's it. Just hit OK. You have got your lower side defect. I'll just redo this. Norm dist for normal distribution. Open up the bracket. Value of LSL will be required because less than 4.5 is defect. Yes, 4.5, comma, mean is 5.1, 5.1, comma, 0.2 as standard deviation, and comma 1 as default value of cumulative. And when it comes to the upper side defect, formula is similar but with a small twist. 1 minus, rest is same, 1 minus norm dist. 1 minus norm dist, open up the bracket. Now, more than what value? Upper side defect. More than what?
5.5.
Absolutely. Comma mean, which is 5.1, comma standard deviation, which is 0.2, and comma 1 as
1.
default value of cumulative. Simple. That's your upper side defect. The total defect will be lower side defect plus upper side defect. Lower plus upper. That's a total defect. What you need to do is calculate the yield of the process. Yield is 1 minus the total defect. That's your yield. You want to get your total defect percentage, multiply with 100. That's your defect percentage, 2.41% defect. Your quality of the process is multiply with your 100, 97.58% quality and 2.41% defect here. So it's a very, very simple formula. Having said that, we have an Excel sheet which is already there in the files that we have shared. Like it's, let me go back to this one. We go back to the folder for data files for class. In the analyze folder, you will see this capability test because we're doing the capability stuff. You have yield calculation. If you open this up, it has got same values in there. See, LSL 4.5, 5.5, mean, standard deviation, the lower side formula, upper side. You change the values. Technically it calculates everything, but I wanted you to know the formula so that you won't be relying on the Excel sheet. You can create your own total defect, yield, and from the same data, see, you are able to calculate the sigma levels also. So we'll try to kind of link up everything. We'll understand how the sigma level can be derived. So at this percentage, what is my sigma level? We'll learn about that. But for now, we have reached at this stage the yield calculation. So yield of my process is 97.58, or you can say quality of my process is this. Defect rate is 2.41% defect. Is this okay with everyone? Yield is the percentage. You convert that into percentage. Yes, yield is percentage rated. And I hope if it's okay with you all, then I'll quickly tell you about the one part of it. Now, one, if you remember, I said like the data, if we have this, let me go back to this one. The same normal distribution function is required. So this is my normal distribution. So this is 4.5. Anything which is more than 4.5, anything which is here, all this is defect. I think more than 5.5. Let's say this is here, 5.5. Everything is here is a defect. So as we discussed, this is going to run till infinity. This is going to run till infinity. It is not ending here. So less than 4.5 will be 4.4, 4.3, 4.2, anything which is less than that. So what you need to do is add up everything, this plus this plus this plus the feature of adding up this plus this, all the defects on the lower side, less than 4.5. That feature has been programmed in Excel as one. The feature of adding up, cumulative, the feature of adding up everything, plus, 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 has been coded or programmed as one. Similarly, feature of adding up here also on the upper side, more than 5.5, 5.6, 5.7, 5.8, 5.9, anything more than that, the feature of adding up all the defects is programmed as one. That's why we use always default value of one in cumulative. So it's there. When you go back here, it gives you the cumulative default one always. Is that okay with everyone?
Yes.
Okay.
Yes.
Now, before we move on to the other metrics, again, would like to kind of reiterate the percentages we got here, the 68.2, that is coming from the norm-dist formula also. I'll just let me quickly make a small data set, just to kind of explain how this percentages in normal distribution work. So let's get these values here, random value. So we know where is it coming from. Oops, let me just copy paste it again. So we're going to take a random data set here, like just not even a data set. Let's assume, so there is a process which is an average of 50 and a standard deviation of 5. So this becomes 55, this becomes 60, and this becomes 65. So an average of 50 and a standard deviation of 5. Less will be 45, 40, and 35. That's how a normal distribution would look like. Now, all we want to prove is that data between 45 and 55 will be 68.2. That's the area of study, like between plus and minus one standard deviation. Now, how do we calculate? Same norm dist formula. Now, how do we keep this in mind? This formula of norm dist always calculates from left to right. That's the limitation of the formula. It always will calculate the area from left to right. That's how it is. So if I want to calculate this area, that this is 60, is this 68.2 or not? That's what we want to find out. 68.2. That's the validation we want. Now to do that, the only method practically I have left with is I will calculate all the area from extreme left, infinity, till this point. That's one. Second, I'll calculate all the area from infinity till this point. Now, if I subtract this from this, will I be left with this?
Yes.
Yes.
Yeah. So I want to find out area on the left of 45 and subtract this from area on the left of 55. That's what we want to do. So subtract the smaller portion from this big portion. I'll be left with only this remaining portion. So norm dist formula, norm dist. Area on the left of 45, less than 45 is the defect. Average 50, comma 5 as standard deviation, comma 1 as cumulative. Area on the left of 55, 50 as mean, 5 as standard deviation, 1 as cumulative. Subtract the area on the left of 45 from 55. This minus this, 68.2. I hope we're clear about this one.
Yeah,
Yes.
yeah.
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 Similarly,
Yes.
you can do this for other also. Plus minus 2 will give you 95.4. If you want to do that, in that case, you will be calculating area on the left of, because then your area will be this. For 95.4% will be plus minus 2 standard deviation will be this, and then you will be calculating area on the left of 40, left of 40, and area on the left of 60, which is this one, this area till this area. This is what we want. So same formula, let's just copy paste it here, and we should get the values. 40 and 60, just change the values, we'll get it. This is 60, area on the left of 60, and area on the left of 40. And subtract this minus this will give you 95.4. Yep. I hope it's clear.
Yes.
Yes.
Okay. All right. So that pretty much brings us to the end of yield. We have two more metrics in percentages. So we'll look at percentage wise metric. And I guess we'll be able to only complete the percentage related metric today. We have throughput yield and row throughput yield, which is left out. In our next session, we will get to this remaining portion. So for that, we will be going to the same folder of analyze, and we have RTY, this file RTY, small file, which will give us both the versions. Let me just increase this font size so that we can have a quick look at this. So there are three terms that we would like to understand here. One is yield. We already know what is yield. Then there is throughput yield, and there is rolled throughput yield. Now, when to use which one? So yield, all are in percentages. So this, let me just give other synonyms also. So throughput yield is also known as first pass yield, first time right, bottom line. So you have got multiple names given to the same thing. Now yield, let's look at this basic example. So there is a process which has started here. There's a process, be it a manufacturing service process, whatever may be the process. There are three stages in the process: step 1, step 2, step 3. So there is a manager 1, manager 2, and manager 3. Different managers are handling different stages of the process. 50 items got into the process 1. That's where my process started. Now, when this processing happened in the stage 1, manager 1 was managing the entire process. We processed these 50 items, the raw material, whatever, and 10 items had some problem. So only 40 items were good, 4 and 6 which were reworked. So only 40 items were good. And when this remaining 10 items were reevaluated, they saw that the 10 items which had some fault, this manager was able to get 6 of them reworked and fixed. 4 were beyond repair. So 40, which was initially good, which had no problem, error free, which is good, plus 6, which this manager was able to rework and fix. So 40 plus 6 became 46. 6 were beyond repair, which we lost. So only 46 moved to stage 2. We lost 4 here, scrapped, completely beyond repair. This was good. So we were able to fix them. 46. Now this manager gets input as 46 only. In his case, there were 12 issues in the product in the second stage, but he was able to kind of fix all those issues and rework all those 12 issues, and he did not lose anything. All 46 moved to the next stage, lost nothing. Now, in this stage, this manager works on it and finds 9 issues in the product, whatever they're working on, finishing product, last, and 9 items were there which were beyond repair. They could not even rework and fix them. 9 lost beyond repair. Only 46 minus 9 leaves with 37. So net, we started with 50 and we got only 37 as an output. The client wanted 50, you gave 37 products. What is the yield of the process? 37 is what you get as net output divided by what was the input, 50, 74%. Yield is reported to the external client. External client will pay you for your product or service depending on what the person gets. So you only gave 37, you'll be paid for 37 only. You would not be paid for 50. Client wanted 50, you gave only 37. So client will say you just met 74% of my requirement. 74% is your client requirement. Like, you don't need to, client doesn't need to know anything what happened in your process. Well, not my problem. Your problem, you deal with it. Don't tell me the stories. What happened, how many reworks, what got scrapped off. Well, I am not interested to listen to your stories. I am just concerned about what do you give me in the end? Simple. Is this good? Yes, I'll pay you for this. 74% quality. That is all. You report these numbers to the client. Yield is for the client, external one. Now, but when you reported these numbers, were you at 74%? Practically not. And that's when you're doing your internal assessment, you're the boss, you want to give feedback to your team. You have continuous improvement drive in your organization. You want to get better. You don't want to look at this rosy picture. This is a rosy picture. It still look bad, but yes, 74 is still a big inflated number. You are bad, like not at 74% also. So this was only for client consumption, not for your internal. You want to fix the process. I want to give feedback to my managers. So manager one, manager two, manager three, respective stage holders, process holders. I want to give them feedback. I will give them feedback on throughput yield. This is the metric for internal consumption. First pass yield, first time right, whatever you call this. Bottom line, I will not give you benefit of doubt for making an error and fixing the error. In the end, I want you to have 100% like product or service right from the first time without any variations. You cannot have a product created or service delivered and then fix it. Well, there's no fun in doing that. Tell me in the first place, how did you make a defect? Well, I will not give you benefit. There's nothing to celebrate. Let's understand what's the first pass yield here. So in case, we'll keep this in mind here, when I see it scrapped, which is what we lost, is equal to rework. It's as good as rework. Scrap and rework, they're same, treated same. For me, you're done. The moment you created the defect, you're done. You rework and you fix it. That's a later story. Practically, if you not have reworked on it, I would have reused the resources material to do something else. But you created a defect and you again utilize the resource to rework. You have kind of consumed my time and money. So this is nothing to celebrate about. So I will be looking for first time right, 100% error free. So 50 items were given to you, minus what you lost, 4, minus you reworked 6, so you had 6 defects in the first place. Only 40 items were error free. What is your net like error free output? 40 items divided by 50. What was your input? You are working with 80% first time right. Your first pass yield 80%. So what it means that you're working with 80% effectiveness. Your process is delivering 80% error free product in this stage. At this stage, 80% error free. 20% you are creating defect. Either you're reworking, you're fixing, whatever. Bottom line, only 80% is error free first time. Now, second gentleman, 46 was your input. You got 46 as input, minus you lost nothing, minus you had 12 reworks. Your error free rate is that was your net output without any error. What is your error free rate? 34 divided by 46. You are the bottleneck of my process, man. Well, there was nothing to celebrate about your zero scrap. You are the real pain that I'm dealing with, 73.9%, which is really, really horrible. Practically, you are the one who's slowing my process. You have only 73 point, roughly 74% of net error free thing. Remaining 26% you are creating error, either in terms of scrap or rework, but you are creating a lot of mess. Let's look at the third manager. 46 minus 9 minus 0. Your error free output is 37. 37 divided by 46, that's your error free, 80.4%. You are the process bottleneck. You are the biggest pain that I'm dealing with. You are slowing down your process because you are delivering slow. This other people will also get slow. So you are the real bottleneck you need to improve upon. So bottom line, when I'm giving a feedback to my process owners, stage level, I should be looking at throughput yield or first pass yield, There's no fun in creating a defect and then fixing it. Ideally, when we looked at 74%, we never counted or we never accounted for this 12 and 6 rework, 18 reworks. I could have utilized the resources for making 18 new products, which I could not because you created a defect in the first place. And client has nothing to do with you rework 100 times, not my problem. You deal with it. I am just going to look at final number. So client is always concerned with the net output. But this is for our internal consumption. You must give feedback to your team, assess your team's performance based on this number. Now comes you are the super boss. You are the super boss. How are you? How is your performance looking like? That's when you look at roll throughput yield, overall process performance. The overall process performance is calculated as roll throughput yield, which is multiplication of first, second, and third. This is your overall process output, error-free output, 47.5%. That means only 47.5% of your items or product or service will pass from beginning till end without any error. That's horrible, and that's what we need to improve upon. So technically, I'm looking miserable here. Like this is your error. So it's a cumulative of all the throughput yield, stage level throughput yields will give you rolled throughput yield. That's what is your net error-free output of the entire process. So we must look into this. This is for client, external, stage level process owners, and your overall process productivity in terms of first time right, error-free product or service. That's how we should assess our performance. Yeah. Any questions from this? Anyone has questions about what we just discussed here?
Yeah. What's the formula again for the first time right?
First time right is
Yeah.
you basically look for net output, like whatever is your input minus the scrap minus the rework will give you the net output. Net output, whatever you get divided by what was the input. So bottom line, what you need, you also kind of penalizing on the rework also. So here say you got 40, 50 minus 4 minus 6, you got only 40 items which were error free. And you divide that with the net input. So 40 was good and the input was 50. You got 80% here. Here, 46 minus 0 minus 12 is going to give you 34. This is error-free output. 34 divided by 46 will give you the error-free rate of this particular stage. Is that clear?
Yes. Yes.
I have a question.
Yeah, please do.
Does scrap and rework are equally bad?
See, technically, when we are doing like we have scrap means we're done with it, right? Rework, in terms of when you're doing a rework, you are technically utilizing the same time, effort, resource to
It's
fix
a
it.
defect.
Handle. We are trying to penalize the process or the people of having the mindset of making a defect. Tell me that you reworked it. You reworked something. I want to understand why did you rework the first, why did you make a defect in the first case? Till the time we don't penalize people on this mindset that it's okay to have a rework, although in the end we fixed it. No, I would have utilized the resources for making 18 new products or services could have been delivered where I kept on working on the same order. That's what it's just more of. So we just look at error free. It's a scrap and rework in terms of first time right. The essence is first time right. What is your error free rate? We're not talking about whether it got scrapped or whether you're able to rework on it. We're looking at how many products get pass through without any error free quality, absolute quality. That's what we penalize. So so before a scrap happened or a rework happened, both started from a defect. When there was a defect in the product, it was either repairable or irreparable. Bottom line, you had a defect in the first place. Something which was repairable, you again got into fixing it. I hope that makes sense.
Yeah, thank you.
Okay. All right. So that's what we have in terms of percentages. So different audience, different people that you will be dealing with, and you have to use these different metrics for different kind of people, because depending on who you're dealing with, you have to give the feedback accordingly. whether it's a rework or technically you have to look at these basic metrics. Like let me just kind of copy paste this information there in the Excel sheet so that we don't lose out this information here. So first this, and then you have these percentages. So okay, let me just kind of copy paste it here. We'll just manage somehow. Okay, yeah. So that's how about your roll throughput yield and all. So when in our next session, we'll go with the sigma level calculation and rest other thing, including the statistical test. So in case anyone still doesn't have the Minitab installed, please do get it done, because then because we're getting to the statistical part of it from here on, almost like we'll get into all the level calculation, everything will get into like Minitab way. So yes, please do have get this installed, and so that you can practice in the meantime. But yes, with whatever data we have, do practice on the attribute agreement analysis, the gauge RNR that we worked upon. We still have like if you can just bear for another 5 minutes, I would like to kind of just give you a quick idea about how Minitab can be used for creating the sheet also, like the gauge RNR sheet. In case we can carry on for another 5 minutes, is it okay?
Yeah,
Yeah, okay.
Okay, okay,
Yes.
no
okay,
problem.
okay. So content-wise, we're not covering anything else here. Like that's what we have. So I will share this this Excel like let me see if I can just do it right. Any which ways, I'll share this. I'll email this sheet over to like IMC, and they will be emailing. But in case you are using it on your laptop or desktop, you can quickly you can pick it from there. Okay, like let me just quickly pick this up, upload. That's where I had this one. IMC. Okay. Like you can click on it, it'll get downloaded, so you don't have to wait for that. So in any which ways, they will share this updated sheet with you because I'll email that to them. Now, going back to Minitab. Uh, so when we talked about triple A, or for that matter, gauge RNR, you can use this method. Like let's have a look at it. So assistant measurement system analysis. So we talked about using the gauge RNR thing. I can use this option for gauge RNR and create the sample file, which will be used. You can print that out and give it to your team for doing this gauge RNR test. So click on this gauge RNR thing. How many operators are there? So I have two operators. How many times would they repeat? Two times. So say I have to give the name. I give them name of John. I will give them name of Paul, and say the two different operators. They have 10 parts. I want to give the name of the part. I can give the name of the part. Like we had pen, pencil sort of thing. So you can give the name also. Different parts. Let me use A, B, C, D sort of thing. A, B, C, D, E, F, G, H, I, and J. So different parts needs to be assessed. Two operators, two times they will replicate. John, just create. See, this is the sheet that you can use and give it to your team who will be required to fill in this sheet. So you just print this sheet and see the parts have been like, so you get the sheet. John needs to assess this part, measured. John needs to assess part, and this has been randomized. See, you don't get the parts in the right A, B, C, D. It's first I part, then B part, then A part, then D part. It's randomized. And see, they are getting the parts the way John is getting the part, Paul is getting part differently. The sequence, the order is different. So it's a randomized thing. So that, and the repetition is also randomized. So the problem or the to kind of note down the measurement is taken care of. Minitab can help you create the sheet. Just need to print this portion and details, your data is ready for analysis. That's for gauge RNR. Having said that, if you're talking about attribute agreement analysis, you can go here, measurement system analysis, attribute agreement sheet. You want to create that, click on this. So you have say two operators, two times they will try. So I have names again, say John and say Peter, not 50 items. I'll say I've got 10 items that I want to check. they're either good, bad, pass, fail sort of thing, and say there is a audit the standard will audit these 10 items beforehand, will say it's good, bad, whatever is the verdict of the standard, which we will not be sharing with these people. So the standard will audit them and will let us know what is the definition of good and bad as per the standard. We'll fix these readings. So standard has audited these 10 items. John and Peter are supposed to match the expectations of this. Let's click OK. We'll just copy paste. So John needs to audit the first item number 5, and give an interpretation, is good or bad. Similarly, John needs to audit the item first, then give a reading of good and bad. And standards reading are right here. So practically you will be able to use this for creating the sheet. Don't share the standard verdict, otherwise people will just copy paste whatever the standard has said. Just get this sheet filled and then compare with the standard. That's how it's done. I hope that's clear how Minitab can be used for creating the sheet. Otherwise, again, you can create it manually also. We know the sample, but it's easier. Like it's easier to use Minitab for creating the sheets. Is that okay with
Kindly
everyone?
explain, kindly
Yes.
explain it again.
Okay, I'll do that. So are you talking about the attribute agreement analysis or the gauge Arner also?
Attribute analysis.
Okay, so assistant measurement system analysis. And here we go to attribute agreement worksheet. We click on this. How many operators are there? How many trials, how many times they are going to repeat, first time, second time, 2 times. Say you want to do it 3 times, whatever you decide. Give their name. Are there which they need to audit and say it's good or bad. These items will be pre-decided, and then you will get them audited by the standard, the expert, who will say it's good or bad well in advance. You know that, which you will not disclose with to the people, and then you get this scoring done, and then click OK. That's it. Now, when you get this scoring done, just take the printout of this area only. Take this printout of this area, give it to people for getting these things audited. And when you get the results here, you have the standard verdict here. It will perform all those 4 criteria, like within operator, expert with the operator, and all operator with experts. So bottom line, you will have the results. You just need to get this at this field filled in. Rest everything that you have to do, like the people will know. John will go and first audit item number 6. John will then audit item number 2. So this is for John. Similarly, Peter will first audit item number 7. So different order has been created for them. Same 10 items are being audited, but in a different order, so that people can't copy and cheat. So cheating can be taken care of, because different people are auditing different things. Same questions, but different people get in a different order. That's how it is. Is it clear?
Yeah, thank you.
Okay. All right. Anyone has any other questions? Any question? Okay, I guess not. All right, then. I guess that's all for today. Let's connect next week. And in case you have any question in between, please do not hesitate to post it on the WhatsApp group. If anyone hasn't joined WhatsApp group, please do join the WhatsApp group, so that we can
Actually,
have. Yeah.
we don't have the WhatsApp group. Okay, for me it is not there, and also I'm not receiving the mails.
Yeah, so just to kind of, because people have been joining in midway also, because I had certain list of the email that was shared with me, and like some people did fill in the form. So that is the reason to avoid that. First of all, I think everyone has got that link I just shared like today. So this link this is the link I'll
Yes,
just.
yes.
So everything that was shared until this session is already there in the link. When you click on it, it will get downloaded. Going forward, I'll be sharing this Excel sheets or anything with IMC, because they have all the details of everyone. So they will be sharing the details of with every participant, because like things keeps getting changed, like new people keep getting added up. So, and some people are not on the WhatsApp group also. So to avoid that confusion, I will be sharing it with IMC, and they will be in turn sharing it with you. By the way, I have attached this Excel sheet right here also. You can click and download, but I will any which ways be emailing this to the IMC team.
Okay. How to join in the WhatsApp group?
So I will ask the IMC team to share the link of WhatsApp group for you to join that. Like, so what, like, I'm sure like when they will share these Excel sheets with you, they will mention it on the on the on probably the link to join.
Okay.
Okay, I'll just in which ways, like, if you can do just ping your WhatsApp number. I will sort of add you to the group. I think like I can ask the concerned person to add you to the group. Anyone who's not a part of the group can ping you their WhatsApp number here. I'll ask the concerned person to add in. Anyone who's not there, please do ping. Is that all? Is everyone else okay? Okay, I guess Sanjay, I guess you are you
Yeah,
not?
I'm already.
Okay, already there. Perfect. All right then. Any which ways, I'm sure like, I'll still ask them to kind of share the link of the WhatsApp group with everyone. I'll share these numbers, but other than this, in case somebody's still left out, they will get covered when they send the email to them. Uh, all right, then let's stay connected on the WhatsApp in the meantime, and let's catch up next week.
Sure.
Thanks, everyone. Take good care of
Thank you.
yourself, and
Thank
we'll
you.
Hi, Mr. Sash.
You too.
yes,
Thank you.
yeah.
Thank
Thank
you.
you.
Bye.
Mr. Sash.
Yes, yes.
Uh, uh, can you please send the file that you sent earlier, the one that you were sharing?
This Excel file.
Yeah, yeah.
Yeah, just give me one quick moment. I'll just email that to you. Yeah, this is it's done.
Okay. Thank you.
Thank you. Thank you. Thanks a lot.